Hello students, Mr. Murphy here. We are moving on to our next lesson, the formal definition of a function. So we're on lesson 2, module 5, and we're going to refine our understanding of the definition of a function. And you're going to recognize that some but not all functions can be described by an equation between two variables. So some functions are our y equals mx plus b type deal, but not all of them can be put into an equation like that. All right, we're going to express in precise mathematical terms the definition of a function, and you'll know you understand it when you hear that formal definition, and then you can explain it to somebody else who doesn't understand what it is. All right. So let's take a look at these tables here. So on this table we have 0.5, 1, 1.52, 2.5. So all of these x's are different, and then all of these y's are different. So as far as we can tell from this table, this should be a function. And if we can figure out the rule from going from here to here, then we will know for sure if it's a function. Here we have 0.5, we have 1, we have 1 again, we have 2, 2.5, we have a 3 again, and a 4. So we have some x's are repeating. Let's take a look at our y's. We have a 4 and a 4. We have a 36, 64, 80, 99, 196, and 256. Now, if I put in a 0.5 and I get out a 4, and then I put in a 1 and I get out a 4, that doesn't matter. Okay? The fact that these are repeating doesn't matter. But if I have a 1 and I get out a 4, so if I put in a 1 and then I get out a 4, and then I put in a 1 again and I get a 36, now I have a problem. And it repeats itself. If I put in a 3, I get a 99, and then I put the 3 back in again, I get 196. So when my x repeats and my y's end up being different, then I have not a function. Okay. So this one on the right is not a function. This one on the left, as far as we can tell, is a function. If we could figure out from the rule, then definitely will be a function. You can't really say it's not because I haven't repeated any x's. But I'm going to say it is because the function happens to be y equals 16x squared, right? So how do I know this is a function? Well, if I put in a number for x, I will always get the same number for y, right? Because the y is 16 times x times x. So I wrote this a little wrong. So if I put in a 0 for x, I do 16 times 0, which is always 0. It's never different. If I put in a 0 again, 16 times 0 times 0, it's still a 0. If I put in a 1, it's 16 times 1 times 1, which is 16. If I put in a 2, I have 16 times 2 times 2, which is 64. If I put in a 3, I have 16 times 3 times 3, so that would be 9 times 16, which is 144, I think. So this is a function because I know, according to the rules of mathematics, anytime I multiply times any number and then I multiply by that number again, I'm always going to get the same answer, no matter what. Okay? So this is a function. That means this table here on the left was a function. Can you be two different heights at the same time? Like, can you be both 4 feet and 7 feet tall at the same time? That wouldn't make any sense, right? You can't be 4 feet and 7 feet tall at the same time. You're one height. So a function of how old you are with the height you are is definitely a function. Okay, so from the day you were born, call that day 0, to the day you die, which is, let's say, day 100,000. You were maybe, okay, let's say the smallest baby ever born was 5 inches and the tallest person ever was 9 feet. Okay? So your range from the day you were born to the day you die, that's your X. Your Y will be some height between 5 inches and 9 feet, but it will always be one height for one day that you are alive. You may be, you may be 5 feet 6 inches tall when you're 12, and then when you're 13, you may still be 5 feet 6 inches tall. That doesn't matter. The fact that you're 12 years old and you're 5 feet 6 inches tall, but not 9 feet tall, is what makes it a function. So a function, if you cannot be two different heights at the same time, then a table of your height for your age is a function, even if it's not a linear function. Okay? A function, so this is getting more formal here. A function is a rule that assigns each value one quantity, exactly one value of a second quantity, right? So in the height things, we have the age and we have the height. So one quantity is the age, from 0 days to 100,000 days. And the height could be anything from 5 inches to 9 feet. So any of these days are valid and any of these heights are valid. But for every one of these days, you will have only one of these heights. It may be the same one as the day before, but each day will only have one height. So I'll go from here to here. I won't go from here to two places. Okay? So the quantity of one value and the quantity of the second value. A function is a correspondence between a set of inputs and a set of outputs, such that each input corresponds to one and only output. Right? These are my inputs, my age, and these are my outputs, my height. And every age will have one and only one height. One and only one height. They may go to the same height, but each input will only point at one output. That's what corresponding means. It will only point to one output. Think of it as a function machine, right? If you put something in, you get something out. Every time you put something in, you get something out. If you put the same thing in more than once, you'll get the exact same answer out every time. So if you know this, you can define a function in your own words. You can recognize a function, hopefully from a table and from a graph. So how do you do that? And then you can create a mathematical formula for some of these functions. For the first one, right, for your age, there's no mathematical formula. You don't grow 0.3 inches every day. But for that y equals 16x squared, that is a function. That is the rule for the function. Every time I put a number in for x, I multiply by itself, and then I multiply by 16, and I get my output. So the x is my input, and the y is my output. And every time I put a number in for x, I always get an answer for that number. And if I put the same number in twice or 100 times, I will get the same number out every single time. So a function is a correspondence between a set. So those are things whose elements we call inputs. So we have a set of numbers we call the inputs, and another set of numbers we call the outputs. They could be the same, they could be different. And each input has one and only one output. If you like to think of it As a machine, it's an input-output machine. If I put something in here, I get something out here. And if I put the same number in more than once, I get the same output every single time. If I put in different inputs, I might or might not get different outputs. Okay, so there's a quiz and an exit slip and all that other stuff in here as well. Good luck. We will see you soon.